G'day. This thing sitting next to me here is a Heine 44J setting down tool. And I got a box of things recently and there are two of these in there. One of them has gone off to hopefully a satisfied buyer. But this one needed some repair work. The handle was missing from it, and so I made up a handle. So today I'm running through how I did that, because although it's a simple part, it's not necessarily a straightforward thing to do. For those wondering what a setting down roller does, it's basically pinching sheet metal between here. So when you bend the sheet metal back on itself, you won't get that perfectly flat. And so these rolls will, by adjusting the amount of pinch you get, will flatten that out, and they can, depending on the gauge of material, you can get it right down to dead squash. So, they're not a common thing, but in sheet metal terms, it's something you need to do occasionally. Those of us who don't have these usually rely on a hammer and just work our way along the seam. But these will do it a little bit more elegantly. It's worth saying something about the handle itself. This is a copy of the one that I had. The original was cast. I've fabricated this. You look at a crank and you think, oh, it's simple, but if you think about what it's doing, if that bit is supplying the torque to something, and you're pulling on here, not only are you twisting that handle, but you're also bending it this way. And so one of the things you do need to do with these things is make them sturdy enough. This one's a nice sturdy one, and the original dimensions are probably because castings can be a little bit dicey. But even so, this is quite a nice design of handle, and it should do the job. Well, it will do the job quite nicely.
This is a drawing of the crank. This has been copied from a crank off an identical machine. So this is what the crank in real life looked like. The original was cast. This one's going to be fabricated, but apart from that, it'll look very similar. That's a wooden piece there. Probably one of the most distinctive features is this arm comes down at an angle of 20 degrees. So I'm going to notch out the ends of a bit of flat bar so I can weld in some bosses, and then I'll come back and bore the bosses and do a few other bits and pieces and all that sort of stuff. I need to have my bit of flat on a 20 degree angle, and I'm using the protractor to set that up, but I've got the end sticking out, and I need to have that there because otherwise it doesn't sit square in the thing. So I've actually used a couple of parallels there. So there's another use for parallels. If you ever need a little bit more height on something like this, there's a good use. Now, I'm going to come in with a milling cutter and do my 25 diameter scallop there. And then I've got an annular cutter, and I'm going to come in and use that for the 40, and I'll show you that in a moment. This thing is an annular cutter, also sometimes known as a rotor broach. I think that's a brand name, but people refer to them as that. If you think about it, they're probably a bit like a hole saw on steroids. They're pretty tough. They've got lots of cutting teeth on them. Initially, I think they were used in magnetic base drills, and you clamp onto that. But people have discovered that for milling jobs where you want a hole taken out, they work well with that. I've made up an adapter here, and so that just goes into cullet chuck. That's 19 millimeters that fits on there. It's a nice snug fit. One of those ones where you get a little bit of air resistance, and you think, oh, yeah, that's nice. So that's a nice fit on there. And I'll tighten those grub screws up, put that in a collet chuck, and then I can use that to scallop the end of my bar there, and that'll do quite a nice job on that. I finished boring out the scallops in the end of my bar. I've also ground that back to give myself a bit of weld prep. What a number of people don't realise or forget or whatever is that welding is an edge process. You're joining edges. So if you want to get a decent amount of weld in there, decent bond, you need to actually dress that back. And the rule of thumb is anything over 3 millimeters, you need to start thinking about, putting some a bevel in there or something so the weld can get down the bottom there. Otherwise, it won't make it. I've made up some bushes to get welded in there. I've put a pilot hole in there because it's much easier to drill out from a pilot hole, but at the same time, I don't want to make it too big because one of the things I'm concerned about is if I put weld along one side, it could distort the part. And so if I've got this finely finished to just the precise bore, I could end up with a flat spot in it or something like that. And then when you try to put a drill down there to take that out, it never ends well. It's always grabs because it's not a round hole. It'll grab on one side. It'll do all sorts of funny things. So that's why that is. So once this is all welded up and cooled and everything's wonderful, I can then go in there with a drill or a cutter or whatever I'm going to use, take that at the final size and know that I'm cutting in good material. I guess the other reason is too that if I take that at the final size and weld it, if this is a bit of mystery metal, but if this is a hardenable steel, I could end up hardening this. So by keeping that hole there small, I'm going to be drilling into the core of the material. It's going to be softer. And so that's another plus for not taking it out to final size when you're about to weld. So anyway, that's what we're up to now. So put that there, I'll tack that in place and then start filling in the groove. I've got my basic crank here. And apart from being cool, which is a nice change, normally I pick things up when they're too hot, I've got it set up for doing this bore. Now, I want to do this one first because I'm going to use that to then locate this. I'll clamp that onto the table and then do that one. In order for the crank to feel good, right, this axis, I guess you'd say, has to rotate in a cylindrical fashion. It's no good this thing being off center and rotating in a wobbly way. That won't feel right. So using a 3-jaw chuck here, I've grabbed the outside. The inside should be concentric with the outside. I put a test bar in here and ran an indicator up the side, and it's not quite as square as I'd like this way, but it's going to have to do. Over that sort of distance I get 0.05 of a millimetre out, and that means a very small shim under there if I want to try and kick that over. So that'll do. It's basically this axis needs to be parallel with this axis, and that's the main thing. Once I've done this one, I've then got options. I can either hold this, clamp this to the bed like so, and then bore this one, or I can trim the sides down. I'll see how we go and what I'm feeling like and how much time remains because I'm running out of daylight at the moment. I tossed a coin and decided I was going to do the sides before I did this final bore here. It probably doesn't matter too much, but two ways to get there. What I want to do is take a cut and come from the surface of that cylinder to the surface of that cylinder and just sort of shave that down. Now, two ways to do that. Or I've done. There's two ways I've done it. There's probably other ways. One is we could measure from the table surface up to the top of that, similarly here, and get them so they both match. And that works. The other way is using a level. You've seen this level before. I've got it zeroed. That's the trouble with the sensitive level. Okay, it's close enough to 0. Using a straight edge across those two, the top of those surfaces, tangent the surfaces, and this one only just makes it. I can put that up there, and fingers crossed, I'm within 3-4 divisions. So this is progress so far. As you can see, I've tapered the handle down. I've only just given that a bit of a go with the flat wheel. This is actually a casting on the original thing, so I'm going to round that off a lot more and make it look a lot more casting like. It's a pity because a couple of those welds look quite nice, but might leave it one in a less obvious place. Next is to bore the hole there and put on the wooden handle part, but I'll probably do all the the railing, the finishing, all that sort of thing before I do that. Here I am ready to drill the hole in here. The bore in here is perpendicular to the surface here, so therefore by clamping on that surface there, the bore or the hole here should be parallel with this one, so that'll give me a nice cranking action. This hole is going to be 10 millimeters for a reason I'll show you in a moment. While I had this thing out, I went over this with the angle grinder and the linisher and just sort of rounded off the corners to give it a more cast shape, and that's come out quite nicely. One of the secrets to making something look like a casting is to radius corners and all that sort of thing, because you don't normally get sharp corners on castings. They've always got a little bit of a radius on them. So by smoothing those out, by getting that taper in and blending the ends of the bar into the bosses on the end here, I've got something that looks very casting like. This is the last piece of the puzzle. What I'm going to do is take off this is a normal cup head bolt. I'm going to take off the square section there and just sort of smooth that down a bit, cut that off, and then counter bore that just enough to go into there. Sorry, it'll go like that. And then I'll probably end up welding that, I think. I could rivet it. The original was riveted, but I've got the welding gear. I feel more confident doing that than otherwise. The only problem, of course, is that I'll have a wooden handle on there, and so I need to make sure that I don't get this too hot. So I'll just have to watch that. But that will then give me a handle which looks very similar to the original. So here it is, the finished handle. Rounded off like a casting would be. I need to throw a lick of paint on that, but apart from that, it's all good. And well, you could tell it from the original, but at a casual glance, you'd say that's actually in keeping with the original bit of equipment, which is actually, according to this, it's a 44J. Before I go, I'd just like to put in a word of thanks to a maternal uncle of mine. I'm told that he's ill and not in a good way. Thank you to him. He and my grandfather, although they didn't teach me any metalworking skills directly, were instrumental in giving me an example of what metalwork could do and how it could be done in a relatively small confine like this. So thank you to him. But anyway, thank you for watching, and we'll see you for the next one.